Hey everyone, welcome to this Forge College Explainer. Today we're diving straight into our CI/CD and deployment pipeline. So this is actually a massive milestone in our from EVM to SVM track, specifically in the full migration capstone. If you remember our last lesson, porting tests and local simulation, we did a ton of heavy lifting, translating our EVM tests over to Solana. It was a great step for sure, but honestly, manually typing out those terminal commands every single time you want to build and test, yeah, that gets old fast. It's a great way to absolutely lose your mind. So today, we're going to fix that. We're taking those clunky, manual workflows and upgrading them to a slick, professional, sleep-saving, automated system.
So what are we actually building here? Think of CI/CD, which stands for continuous integration and continuous deployment, as this highly efficient automated assembly line. Imagine you've got this tireless little robot assistant whose only job is to watch your code. Literally, the second you hit push, it springs into action. It grabs your Rust program, compiles it with 0 typos, by the way, runs all your test harnesses, and then only if everything is absolutely perfect, it gates the deployment and packages it up. It completely takes all that messy human error right out of the equation.
All right, let's take a quick look at the blueprint for our factory setup today. We're going to cover why we need to automate, the build and test phase, the strict deployment gate, keeping our secrets safe, running smoke tests, and finally, validating the whole CI setup. Let's just jump right in. Section 1, why automate your pipeline? Let's talk about the real benefits here. Now, you might be sitting there wondering, look, my local testing works totally fine. Why do I need to build out this whole complex pipeline? And honestly, it really just comes down to reproducibility and scale. In Web3, you just can't rely on that classic, well, it works on my machine excuse, right? Back in your hard hat and Foundry days, you probably had a super reliable pipeline that let you sleep peacefully at night. And as we migrate over to Solana and Anchor, we want that exact same operational parity. We're basically trading in those old, hand-cranked manual scripts for a fully automated rocket launcher. Moving on to Section 2, the build and test phase. Time to establish that deterministic workflow. This right here is the absolute heart of continuous integration. Our main goal is to translate your manual commands into what we call an idempotent script. That's just a fancy way of saying that no matter how many times it runs, it's going to produce the exact same reliable results. Every single time you push code, the automated runner takes the wheel. It sets up Rust and Node.js, installs the Anchor CLI, compiles your program, and then fires off your JavaScript or TypeScript test harness. There are no interactive prompts waiting for you to hit Y, no weird mismatched software versions, just a perfectly sterile, consistent testing environment. Now, a super crucial detail during this phase is making sure you use the anchor test skip deploy command. Because at this point, we just want to know if the logic actually works. The absolute last thing we want is the pipeline accidentally overwriting our staging environment with some half-baked code. By tossing in that skip deploy flag, Anchor just spins up a local validation environment, tests your logic right in memory, and then cleanly tears it all down. Which brings us to Section 3, the strict deployment gate. This is where we enforce the rules.
Think of this as the VIP section of our pipeline, and it's guarded by the most uncompromising bouncer in Web3. Deployment only happens if conditions are flawless. It's called test gating. If your test suite fails, even if an account balance is off by literally a single LAN port, this bouncer stops everything dead in its tracks. The pipeline flashes red, the deployment aborts, and your target clusters stay completely safe from any buggy code trying to sneak through.
All right, Section 4, keeping your secrets safe. We got to talk about secure key management.
So we made it past the bouncer, right? But how do we handle the armored car that's transporting your sensitive data? Let me be crystal clear here. Accidentally hard-coding a deploy keypair into your public repo is basically the fast track to a very bad day. Unless you're looking to involuntarily sponsor a malicious bot's early retirement, you must never put private keys in your code, ever. Instead, we're going to lean on your CI provider's secrets management system.
Here's how we actually use those CI-managed secrets to safely inject our data at runtime completely outside the codebase. It's actually pretty brilliant. We store our deploy key as a base 64 encoded string safely tucked away in the CI settings. When the deploy job kicks off, the pipeline decrypts it, uses it to sign the transaction, and then just immediately vaporizes that temporary file. We also parameterize our cluster URL via HTTPS, so deploying to localnet, devnet, or mainnet is literally as simple as swapping out a variable. And you can even throw in a cache token if you want to speed things up.
Okay, Section 5, smoke tests and rollbacks. Time to verify that deployment. So once the deployment pushes through, our factory alarm system kicks in just to make sure nothing is secretly on fire. Because, just because a command finished doesn't necessarily mean our job is completely done. Your deploy script has to be rollback-aware. We run what's called a smoke test. This means we decode that temp deploy key, run the anchor deploy, and then we actively query the Solana CLI to ask, hey, does this program ID actually exist on the cluster? If the cluster says no, the script exits with a non-zero failure, throwing an error so your front end doesn't end up trying to talk to a ghost program.
Finally, Section 6, validating your CI setup. Let's make sure this matches your old workflow. All right, it's inspection time for our automated factory. We don't just build these complex pipelines and, cross our fingers. We validate them. First, trigger a push or a PR. Watch those logs and observe the build success. Next, and this is fun, intentionally break a test just to confirm that our uncompromising bouncer actually stops the deployment failures. Once you fix that error and watch it pass again, you have successfully validated your target deploy. You've proven that your pipeline only promotes tested, successful code.
And let me tell you, seeing deploy succeeded, followed by your program ID in those CI logs, that is the ultimate proof that your Anchor program safely navigated the whole journey. It means it was cleanly checked out, deterministically compiled, rigorously tested, safely signed, and actively verified. You've essentially taken your prior EVM automation standards and successfully mapped them perfectly onto the Solana virtual machine. So the pipeline is fully operational. You've preserved not just your code's functionality, but that critical operational safety net that guarantees your repeatable releases. But here's the real question. Now that the robots are handling all your deployment busy work, what kind of incredible Solana dApp are you going to build with all that free time? All right, that wraps it up. This explainer was brought to you by Forge College. If you want to dive deeper into this and other awesome Web3 topics, or just continue your journey mastering the SVM, definitely go check out forge.college today. Keep building, have fun, and we'll see you in the next one.